Today we're going to play a little catch up. We've got to simplify radicals. We've talked about how x to the 1/2 is the square root and x to the 1/3 is the cube root. Well, let's simplify those once we get them into radical form. If I, of course, have the square root of 4, everybody knows that's 2. The square root of 5 cannot be simplified. All right, there is no perfect square that divides evenly into 5. Well, perfect squares. Well, here they are. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. You can keep this list going on for quite a long time if you wanted to or needed to. Up to 12, maybe 13 is probably what you should have committed to memory. But 4, 9, 16, and 25 are the perfect squares. And so when I'm taking the square root of 20, or when I'm simplifying the square root of 20, I'm not evaluating, I'm simplifying the square root of 20, I want to find the largest perfect square that divides evenly into it. Well, I certainly wouldn't have to check 25 because that's a bigger number than 20. 16 does not go evenly into 20. 9 does not go evenly into 20. But 4 goes evenly into 20. And so I've broken the square root of 20 down into the square root of 4 times 5. And the square root of 4 times 5 can be broken down into the square root of 4 times the square root of 5. And of course, we just found out here the square root of 4 is 2, so that 2 goes on the outside of a radical, which leaves the square root of 5 underneath since it cannot be further simplified. In a similar fashion, the square root of 90, all right, 25 doesn't go into it, neither does 36 or 49 or some of those others, so 16 doesn't go in evenly. 9 is actually the largest perfect square that divides evenly into 90. So I broke it down into the square root of 9 times 10. Of course, 9 times 10 is 90, which then breaks down into the square root of 9 times the square root of 10. I take the square root of 9, and that's 3. Notice that I do no longer have a radical over that 3. But that square root of 10 does not simplify any further. There's no perfect square that divides evenly into it. So my answer, or the simplification for the square root of 90, is 3 times the square root of 10. It also works for variables. All right? We have perfect square variables. X squared is a perfect square variable. All right? The square root of x squared is x. All right? And here are the perfect squares. Again, x square root of x, if I take x and I square it, I get x squared. If I take x squared and I square it, I get x to the 4th. If I take x cubed and I square it, I get x to the 6th. X to the 4th squared is x to the 8th. So notice that these perfect squares, all right, of variables are all even. All right, are all even. So so the square root of 4, the square root of x to the 4th is x squared. I had to square x squared to get x to the 4th. Well, x cubed, all right, jump back up here to x cubed. X cubed can be broken down into the perfect square x squared times x, which then can be broken down into the square root of x squared times the square root of x. And this is just simplifying it. You won't have to show this step in the future. Square root of x squared is x, and since there is no perfect square that divides evenly into x, that square root of x stays, that x stays underneath the radical, and the x that I took the square root of x squared by to get stays outside. X to the 5th. Well, the largest perfect square, again, is that even one. All right, so it's x to the 4th. All right, x to the 4th is the largest perfect square that divides evenly into x to the 5th. It's x to the 4th times x, and we found that the square root of x to the 4th is x squared. So I pull the x squared out and left with the x underneath the radical. So the simplification of the square root of x to the 5th is x squared times x. So we combine it all together, numbers and the letters. Largest perfect square that divides evenly into 45 is 9, so that'll be 9 times 5. Largest perfect square that divides evenly into x to the 7th is x to the 6th. So that breaks down into x to the 6th times x. Square root of 9 is 3. Square root of x to the sixth is x cubed. You can see it right here. I had to square x cubed to get x6. So the square root of x to the sixth is x cubed. Sort of, they go back and forth. All right, so that x cubed comes out front, and I'm left with this 5 and that x, which stays underneath the radical. And now we take the next step into cube roots. Well, the cube root of x cubed is x. They sort of undo each other. The cube root of x cubed is x. And we want to know the largest perfect cube that divides evenly into x to the fourth. Well, notice here, these are the perfect cubes for variables. Notice they're all divisible by 3. All right, that's your hint. 3, 6, 9. That's how to find them. All right, x cubed is x cubed. X squared cubed is x to the sixth. X to the third is x to the ninth. All right, so what's the largest perfect cube that divides evenly into x to the fourth? That would be x cubed. And x to the fourth is x cubed times x. And then I take the cube root of x cubed, that's x, and I'm left with x times the cube root of x. The cube root of 8x to the sixth, well, the largest perfect cube that divides into 8 is 8, and it's the perfect cube of 2, so the cube root of 8 is 2. The largest perfect cube that divides evenly into x to the sixth is x squared cubed, so the cube root of x to the sixth is x squared. Let's take that a step further. The cube root of 16x to the eighth. The largest perfect cube that divides evenly into 16 is 8. The largest perfect cube that divides evenly into x to the eighth is x to the sixth, and that comes from this list over here. So I take the cube root of 8, that's 2. I take the cube root of x to the sixth, that's x squared, and I'm left with 2 and x squared up under this cube root symbol. So the simplification of the cube root of 16x to the eighth is 2x squared times the cube root of 2x squared. And for your post, please tell me what you think the fourth root of x to the eighth is. And of course, post if you have any questions.